presentation mode?
Yes.
Awesome. So hello everyone. Good evening, good morning, good midnight to my friend. But thank you so much for taking your time for joining this session today. It is a pleasure to be able to speak in this user group. I have spoken in this user group at the Glass user group in the past several times, as Michael said. It is so good of Michael for giving me the opportunity to speak here multiple times. Hopefully, I will be here in the future as well. So today I would like to talk about the SQL Server 2022 advanced features. So hopefully you like it. There is a lot of content to cover, so please be patient with me. I'm not feeling well. I have cough going on with all the allergies and stuff. So please don't mind if I blow your ears couple of times today. So I'm just saying I apologize ahead of time. So yeah, let's get started. A little bit about me. I'm a database administrator. I have about like 8 years of experience as a DBA, and also I'm a data platform MVP. Mm, I did my master's in computer technology like 7 years ago. And also, apart from my job as well as my community work, I also do organize user groups. Since my friend is here, I work with Kai Soter with the data TGIF user group. I recently joined his user group. He's a owner and founder of the user group. So if you would like to join the virtual session, I will also suggest you to search for data TGIF in the meetup so that you'll find the group and you can join as well. That's a complete virtual user group. And also I do organize data and AI South Florida user group. This group is also been virtual. If you search on meetup, you'll find it. And also I'm a co-organizer for diversity, equity and inclusion user group. Again, my friend Kai Sauter is also part of that user group. And I also volunteer Women in Technology user group, and also I volunteer women in IT. So I usually, I give them the suggestions and like support them for their career. And apart from my work and my community work, I love plants. I love arts and crafts. Um, and I love watching movies as well. So if you have any questions, like if you can definitely ask here. But if you are shy and if you couldn't ask the questions here, you can definitely contact me on LinkedIn. I'm very active on LinkedIn and on Twitter as well. But these days I'm not using much of a Twitter. But I have my blog post over there, like dbanuggets.com is my website. I usually blog about SQL Server and Azure. So if you like, you can go ahead and look into it. So our agenda for today is to talk about the SQL Server 2022 features, which we need to first talk about query store hints because first talk about query store, not even the hints query store, because the all the IQP features that you are seeing below the first point, the last three set of points, memory grant feedback, degree of parallelism feedback, cardinality estimate feedback, all of these three IQP features they depend upon the query store. So we need to start talking about the query store and a little bit on the query store, how what happens behind the scenes and what are the query store hints, and then dive deep into the IQP features. But I did not mention here PSP optimization, which is parameter sensitive plan optimization. Even this is a IQP feature in SQL Server 2022, but it doesn't depend upon the query store. So even though you disable the query store, parameter sensitive plan optimization still work, but the rest of the IQP features might not might not use the query store anymore if you disable the query store on SQL Server 2022. So let's start. So like I said before beginning, let's see how the query store actually works behind the scenes. So it will give an idea of like query store and then we can talk about the rest of the features. It will align properly. So let's say a query actually whenever a query executes on the SQL Server, it first checks whether it is running for the first time or whether it is running for like whether it run executed before. If it is running for the first time, then it will go ahead and do the compilation and the optimization. It will go through this process to build a execution plan. But if it is not running for the first time, then definitely there can be a plan in the cache, right? It already existed. But in some scenarios, the plan in the cache won't be there. Like for example, whenever there is a eviction, like whenever there is a memory pressure, the first thing that happens is SQL Server will go ahead and evict all the least recently used plans. So the plan might not be there. Or if you restart the SQL Server, then again all the cache is like plans are gone from the cache. So in that case, the plan won't be there. So if the plan is not there, right, then it will go through the compilation and optimization phase again to build a new plan. But if there is a plan already in place, then all right, it will go ahead and take the plan from the plan cache. But if you have a query and you enable the query store on the database, let's say, and one of the advantages of using the query store is to if you can force a plan. Like if you think a plan is working properly, you can actually force that plan so that the next executions will use that forced plan. So at this point of time, it will go ahead and check for the recompilation. It will check like if a plan is not there in the cache and if I build a new plan and this particular query that you are running has actually have a forced plan in place. Now that new plan that got generated in the cache, is it similar to that forced plan? It will go ahead and check. Sometimes it won't be the same. For example, if you force a plan with the query store, right? And then you made some modifications to the indexes, let's say, with that particular index is inside the plan that you forced. And because you modified the index in the plan, index index which is used in the plan, it will automatically reject the plan and then build a new plan. So, and then many things like the plan might not be in the cache, it can get evicted and create a new plan. It might not be the same all the time, right? Because data gets inserted, and it can be OLTP systems, lot of data get inserted. Statistics might be stale. It can be any reason. It can generate a new plan which is not similar to the force plan. Then if it is not similar to the force plan, then it will go ahead and apply that force plan forcefully, right? Because we forced a plan, it have to use that plan. But if there is already the plan that got generated is similar to the force plan, then it will move ahead and use the same plan. But before going to the execution phase, right, the query goes to the execution phase, the first thing that happens before the execution is that it will take the query text and the query plan of the query and it will put in the plan store. So when you enable the query store on a database, it will actually enable two different kinds of stores in the memory. One is plan store and the other is runtime stat store. So these two stores gets activated in the memory. So before the query goes to the execution phase, the query text and the query plan, both of them will be saved inside the cache. And then the query goes to the execution phase. Query needs to be executed to collect the runtime stats. Runtime stats can't be collected before the execution. So the query have to go to the execution. So once it's executed, the runtime stats will be also saved inside the runtime stat store. This all will be saved in the memory. So this process will happen asynchronously. And once the data is being collected in the memory in these stores, every 15 minutes by default, there will be a flush out interval happens. During this flush out interval, all the data that has been collected here in the memory will be flushed out to the query store schema. So where is this query store schema um, present? The on the database where you enable the query store, it will save that data in the same primary data file of the database in the system tables. And you can query the query store schema by using the views, system views within the database itself. So that is the process of the query store. That's how the query store will actually save the data in the same database, primary data file of the database. You cannot change the location where the data is being stored. So that is how the like topology, like you can say behind the scenes of the query store. Now, you might be thinking like we already have a plan cache and plans are in the plan cache. Why do we need the query store? The main difference is like with the plan cache, there are several scenarios where the plans get evicted out of the cache, and all we have is the recently used plans in the plan cache. And we cannot rely on the plan cache because not everything gets stored inside the plan cache, like CPU memory and IO information and the execution stats information. All of that information is not stored, and you don't know when those plans will be kicked out of the cache. But with the query store, as all the data will be collected over time, the data will be retained even upon the restart of the SQL Server. And you have the ability to choose the configuration options of when to clean up the old data. So the cleanup policy is 30 days by default. You can set that up. Like you can also choose like what kind of queries you want to store inside the query store. You can set the custom design policy, custom policy, and based upon, so inside that custom policy, you can choose the threshold, like CPU threshold. Um, you can set the CPU threshold. So once it hits that CPU threshold, then only the query will be stored inside the query store. Or you can also choose the threshold of the CPU limit, as well as how many times the query have to run to be eligible to be stored inside the query store. So that's the difference. With the plan cache, you can't rely on it because that is not the collection of like saving the data over time. You can lose it anytime. So the advancements that we have in SQL Server 2022 is query store is enabled by default. All the new databases that you create will have the query store enabled. But if you are migrating the database from the old versions to the SQL Server 2022 environment, then you need to manually go ahead and enable the query store if you'd like, because they do not change that setting automatically. And another improvement is if you are having ad hoc workloads, right? Too many ad hoc workloads, so many ad hoc queries running on your SQL Server, they have the internal memory limit. So if a certain amount of internal memory limit is reached, the query store will automatically go to the read-only mode, and until it clears out the memory to be available for the queries again. And you also have the ability to clear out the ad hoc queries by using a query. If we have a query in the Microsoft Docs, you can actually copy the code and then use the SQL agent job and schedule it to run it on scheduled time to clear out the ad hoc workloads that are in the query store, saved inside the query store. And of course, another advancement is query store hints. So we are going to talk about the query store hints and one of the IQP features in the demo. But before going into the demo, I will also talk a little bit about the intelligent query performance features. So this slide shows all the IQP features that are available all the way from SQL Server 2017 to SQL Server 2022. Because we are talking about SQL Server 2022, we have the highlighted blue in color. All of those features are added in SQL Server 2022. So apart from parameter sensitive plan optimization, which you are seeing on the top right side, Apart from that particular IQP feature, rest all IQP features will use SQL Server 2022 query store. So they are all the feedback, all the IQP features feedback is collected from the data which is collected over time from the query store. So before talking about the IQP features, the highlight to use these IQP features, you do not have to make any code changes, but you need to make sure you are putting the database in the SQL Server 2022 compatibility mode. And if a query is actually using one of the IQP features, it can use multiple IQP features together to make the performance improvements. So you will definitely see an improvement in the query performance once you enable that database to the SQL Server 2022. We have discussed the query store advancements, a couple of them in the previous slides, but the additional ones that I didn't talk about are if you're having the availability group, always on availability groups, before SQL Server 2022, you do not have an option to capture the data on the secondary, on your secondary replicas. But with the SQL Server 2022, you can also have the data captured on the secondaries. So how do you do that? Your secondary replica is read only, right? So to enable that, you have to connect it to the primary replica and enable the query store to be collected on the secondary replica. So you run all the queries that are needed on the primary replica itself. So it will enable the query store on the secondary. So basically, because the secondary database is always read only, it cannot save the data on the secondary. So what it will do is all the queries that you are hitting on the read only, it will collect the information and it will use the same exact channel that will send the data from the primary replica to the read only replica to send the data to copy over the data, right? From primary to secondary. It will use the same exact channel in the backway direction to send back the data, the query store data, collected data to the primary replica. So the data is always collected on the primary replica, the database where you enable the query store. There are options to choose whether you wanted to collect the query store data on one secondary or all of them, including the primary. You can just choose the primary, or you can also use the secondaries along with the primary, or just use one or two secondaries. There are plenty of options you can choose from. So like I mentioned all of the IQP features here. So before going into the demo, right, I will go to a demo right now. After talking about like parameter sensitive plan optimization, I will show both of them, the query store hints as well as PSP optimization together as a demo. But before moving further, do we have any questions?
Yeah, there was one that popped up in the chat just asking about the defaults not changing for migrated databases. They asked, is it based on whether you leave the compatibility parameter or update it to match the 2022 upon upgrade? And my thought was, if it's an existing database, it'd just be a matter of whether the database already had a query store already set up or not. Whereas, like, if you're creating a new one, it would go
It
with
will
the default.
automatically.
Yeah.
Yeah, it will
Now,
definitely go with the defaults if you're creating a new database.
yeah. Now, do you know, so like if you had a database with query store enabled in a 2019 database and bring that over, assume that would just, it would have
It will
query store.
not turn it off. It won't turn it off, the existing one.
Yeah, so if you
If
have
you
it,
if you do not have it, then you need to enable it once you move to SQL Server 2022.
and if there's updates in the from 2019 to 2022, as far as how the query store operates, you may want to probably update the compatibility level to be the current version, I would assume. but because if you
Uh,
over a 2019 database and it's 20 like a compatibility level of 2019, I can see where
yeah,
you
if
may
you
take advantage of all the 2022 features.
exactly it's to take the advantage of IQP features, you definitely have to put the database in the 2022 compatibility mode. Otherwise, you are still running it on like 2022 environment. You are still running the 2019 database. It's just like that. But
Yeah,
until you enable it, none of these IQP features will be
right.
worked. You need to first update the compatibility level.
Yeah, perfect. All right, sounds good. Any other questions before we move on? I think we're good.
Awesome. So let's talk about the parameter sensitive plan optimization. So it is also known as PSP optimization. Um, so basically, this is the only IQP feature which doesn't depend upon the query store because it have its own topology on the top of it. So there is something known as, when we talk about PSP optimization, there is something known as dispatcher and variant plans. We need to talk about the dispatcher and variant plans. So let's take an example of how this actually works. So let's take a query which is very sensitive, like which have a very sensitive parameters. Let's say you have a database and most of the tables, right? You have the flow of the data is like you have a skew in your data. Definitely, if we have a real-time data, we definitely have a skew in the data, right? Couple of your parameters, let's say you are executing a store procedure and one or two parameters will are like they produce too many records, like 1 million, 2 million records, but most of your parameters for that store procedure just give like couple of hundreds or thousands of records, let's say. And then like because of that situation, right, that's a parameter sniffing problem. You usually solve that problem by using the recompile or by using the plan hints, right? Like not the plan hints, but query hints. Usually use the query hints. Or you'll use the, if you are using the query store, then you will use the query store hints to query store hints, for example, recompile by using the query store store procedure. We have a specific store procedure. We can use the store procedure by mentioning the recompile option. We can do that without changing the underlying code. But with the, if you are in SQL Server 2022 compatibility mode on SQL Server 2022, then this option PSP optimization will be turned on, meaning like if you are sending that particular parameterized query, then you have something known as in memory. This is all in memory, something known as dispatcher plan. Now, dispatcher plan is like a logic. It is like a logic which have all the information, like um, it have like, okay, what are the parameters that are coming to me? So this set of parameters need to go through this way, like into this branch and use this particular plan. So the dispatcher plan contains all the logic of statistics, like what kind of like that it have to go and fetch for the statistics to find how much of memory grant it have to allocate, what kind of plan it have to use. So you might be thinking, well, the plan, it is just one plan that gets generated and it will be saved inside the plan cache, right? Generally. But in SQL Server 2022, for the PSP optimization, up till three execution plans will be saved inside the cache per query. Depending upon your parameter value, it will go ahead and use the plan which is suitable for that particular parameter. So let's say we have we have it we are searching on a table which have agent. We are searching on the agent, okay? Agent which have less than 10,000 listings, more than 10,000 but less than 1 million, or like more than 1 million listings. We are searching on that particular column. If If the agent is less than 10,000 listings, then the dispatcher plan will send the logic, like it have that logic to go ahead and use a plan which have seek and the key lookup and a very small memory grant. But if it is more than 10,000 and less than 1 million listings, then it will go ahead and use the plan which is already cached, scan plus memory, medium memory grant. And if it is more than 1 million listings, then it will go ahead and use the large memory grant with the scan. So as the dispatcher, as the parameter queries, like different parameter values of that particular store procedure coming in, it will build the logic inside the dispatcher plan. So let's say let's say the parameters have to come in and the queries have to run, like the particular store procedure have to run with different parameters to even have that logic in place within the dispatcher plan. So it will build up till three different plans in the cache. So it like previously it has only one plan, but because it is having like three different plans, now most of the parameter sensitive problem will be solved most of the times, because you do not have to have to juggle with like doing the recompile or anything. So dispatcher plan have the logic, and what about the variant? What is this variant? Variant is nothing but the execution plan. The plan itself is known as variant. And in our demo, I will show you like how the dispatcher plan will look like and how the variants will look like. Let me go ahead and share my management studio to show you the demos. We have two demos in this session. So first one, we will go ahead and see the query store hints, right? So I'm connected to SQL Server, like Azure SQL database, but this is the exact same thing on SQL Server 2022 as well. The only reason why I'm using the Azure SQL database is here that I have everything in place in Azure SQL database. That's the solely reason that I'm using here, but it's the same exact thing on SQL Server 2022 as well. So, um, so previously, like if you do not have the query store hints, if you are using the query hints, right, you need to edit the code itself. Like you have this code, you have to mention the option, and in the brackets, you have to mention recompile and any other hints that you are using. You need to mention by editing the code itself. You have to touch the code underneath code, right? I just put it out there to just show you how we use that. But here in our demo, we are going to see how to use the query hints with the query store. Now let me go ahead and create the store procedure. Very simple store procedure. I'm selecting couple of columns and using the where clause, where product ID, and using the product ID parameter here. I'm just executing it. I hope this will work because I put my Azure SQL database as um, a bit, yeah, it worked. So now I'll go ahead and clear out the query store. Do not do this in production, not even in the development, because it will clear out everything. But in my demo, I would like to do that. Set query store clear will clear out. And then I'm clearing out my cache. So now in Azure SQL database, the query store is automatically turned on. If you try to turn it off, it will throw you an error. It is a must to be enabled. So I right now we created the store procedure. These two parameter values, right, are very sensitive. When you execute it with actual plan enabled and then execute it, the first execution, if you see the bottom right corner, you see 360,000 records for that particular parameter. But for the second parameter, we see only 385 rows. Lot of difference, right? For two of them. But if you see the execution plans, after we created the store procedure, the first time you run with any parameter, it will generate a plan and it will put that plan in the cache, which is clustered index scan in this scenario, which is okay for those many number of records. But with this, but with this execution for 385 rows, we do not have to um, do the clustered index scan. It takes a lot of resources to execute this query for such small number of rows. This is the scenario if you are not using the query store, right? If you're not using the query store, the first execution will be saved and the same execution will be used next time. So no matter even if you have um, the parameter values 90% of the times, which only gives like hundreds of records, doesn't matter if you like, it doesn't matter. It only matters until a correct plan is placed inside the plan cache. If the non-optimal plan in this scenario, it is a non-optimal plan. Most of our parameters need the clustered index seek and a key lookup, but here it is using clustered index scan. So if you are not using the query store, right, the only option is to do the recompile option in this place. We need to edit, touch the code. So here, because we are using the query store hints, all we have to do with the query store hints is two-step process. Number one, you need to find the query ID of that query you are running. The next step is to use the query store a set hint store procedure, which is specially designed for the query store to use the query hints by using the query store. So this query, I'm actually searching with the like operator by using some of the code from that store procedure and executing it to see the query ID. Query ID is 1 for that particular store procedure. So all we have to do is we have to execute the SP query store set hints, which is a store procedure, right? It have two parameter values that we need to pass, the query ID, which is 1, we just find it out, and the value, what sort of hint that you wanted to use. In this scenario, I would like to use a recompile. So let me execute this. And then let's see like what query store hint is enabled. To see the list of hints that are enabled, you can run this particular view, query store view, query hints view to see. So the query ID is 1. And then I have updated the query hints this morning couple of times. So that is the reason you are seeing query hint ID 3. But usually when you first do the add the query hint on that particular store procedure, it will show as query hint ID 1. And on the query ID 1, are you able to hear me?
Yes. Yep, we can hear you.
Okay, thank you. Thank you. So the currently applied query hint is option recompile. So now it's enabled, right? Now let's go ahead and execute the same exact um, store procedure with the same parameters again. Now let's see the execution this time. Um, Depending upon the parameter value, it went ahead and it did the clustered index scan and the index and key lookup for that 385 records execution, which is good, right? It is saving a lot of resources. It is not using any unnecessary resources to execute this particular execution, just to give us the 385 records, which is good. But what if you want to use multiple hints at the same time? You can use multiple hints at the same time. You have to do just, you need to just append the number of hints that you are using. You do not have to remove it, because if you remove it, it will override the existing one. So you need to just append the number of hints you wanted to use. If you want to use any update the compatibility for that particular query, put that as a comma and then add it to maintain the existing hints. So let's say I would like to also put the max stop as 1 for this query. So let's execute the store procedure with the query ID 1 and then appending the max stop 1. And let's go ahead and see what query hints are enabled currently. If you execute it, now previously the query hint ID was 3, now it turned into 4. And the option was like recompile and max stop 1. Now, did you observe like if I went like if I'm working in the real time environment, right? And if I went ahead and saw what query hints are there on this particular store procedure and I see this on my screen, I have no idea what was the query hints for 1, 2, and 3. Somebody might have updated it on 4. I did not do it. So and developers might have the ability to do it. They might have owner permissions onto the database. They might have a schema, like they might have the permissions on the schema. Now I need to know like what was my query hints. Now, if I want to roll back, I need to know what it was, right? So by default, it is not available. That information is not by default available. If you want to capture that information, you can use extended events. And to know how to actually set up that extended events, I have written a blog post on it in my on my website dbanuggets.com. If you can go ahead and search for the query store, you find all the blog post about query store. You'll find one of the blog posts talking about it. So currently we have these two options enabled. Now let's go ahead and clear out my cache and then run the same executions again. Okay. Now if you see the clustered index scan, index seek and key lookup, both are that particular recompile is working fine. To check whether the second one, right, the recompile as well as maxstop is working or not, you just go ahead and check the properties, and here it will mention like maxstop set to 1, and then what kind of query store hint is being used, option recompile as well as maxstop 1. You can check that in the plan itself. So if you want to clear out the query store hints that you have placed on a query, you can just give the query ID and you can clear out that any of the hints that you have on that particular query. Now, if you see, none of the query hints are there anymore. So that's the query store hints demo. Now let's go ahead and talk about the PSP, parameter sensitive plan optimization. So for this, I am using SQL Server 2022 and I'm using Stack Overflow database. Now, because I restored a Stack Overflow database on SQL Server 2022, it don't have the query store enabled. So I need to enable manually. So I'm enabling the query store operation mode read write. And then I'm updating the configuration options. Like I'm not going to talk detail about like what configuration options. I have a query store sessions separately. You can check that on YouTube. Like type my name, Deepthi Goguri and query store. You'll find my session. I talked a lot about the configuration options, but here in this session, we are going to talk about the features. So let's go ahead and execute. And so if you enable the query store, to set the compatibility mode 160, which is SQL Server 2022, it should automatically enable the parameter sensitive plan optimization. But if you disable or like if you want to enable by using the transact SQL, alter database scoped configuration, set parameter sensitive plan optimization is equal to on, will turn on the that particular option. Now, let me go ahead and update that to SQL Server 2022. So now this particular this IQP feature is enabled, right? Now I'm just going ahead and creating this particular store procedure. Very simple. All it is doing is selecting select star where reputation is reputation. Reputation is the variable here. Now we are ordering it by display name. Now let me go ahead and run this. We created the store procedure. Now, if you see, I am searching on reputation column, right? Now, whenever a query gets executed, the first thing that SQL Server rely on, main important one to execute any query, it will rely on the statistics information, how the statistics are looking like on this particular column, because on where clause we are using reputation. So let me go ahead and search the statistics on the reputation to make an estimate of how many rows I might get out of the execution. So it will go ahead and check the statistics. So here I'm going ahead and searching the statistics information on this table and on this column. So I want to show you how the statistics look like. So statistics, this is the statistics information on the column reputation. If you do not know about the statistics is nothing but it is a table-like structure. Um, Mostly when you create an index on a column, SQL Server will automatically build a statistics. It's a table-like structure like this automatically for you if you are creating any indexes. Also, if you run any query and if the column within the where clause do not have an index on it, SQL Server will also go ahead and create a statistic on that particular column automatically. So, for example, this is an example of how the statistics look like. It is just like a table structure describing the skew of your data, how the data flow is looking like for that particular column. And it is always less than 200 records. If you see the maximum um, records that we have here is 194. So it cannot go beyond 200. It is always below 200. Now, how do we read this, right? You need to mainly focus on equal rows and range high key value. Now, range high key is nothing but the value itself of the reputation. So, what it is saying for the reputation ID 1, for the reputation 1, we have these many rows. For the reputation number 31, we have these many rows. Now, I have ordered this, like if you see, I have ordered this particular query uh, by equal rows descending order. So, it gave me like from the high number to the low number. Now, if you see the lowest number here, this particular reputation have only one record. So based upon how many records we have, I choose the toppest equal rows and somewhere in between the medium rows, and I have created this demo. So for this particular reputation, we have so many records. Let's see for this, let's see how many records it generates. So each of this execution, I am executing for 3, 2, and 3 times. So let's execute and see how the execution looks like. It is still executing. Let's let it execute. We will see how the things are going. It's still executing, but if you observe the first 3 executions, right? How many records did it give? 8 rows. The first 3 execution, 8 rows. The next execution, did you see there? Like so many. How many? Like if you see the second, and the third is 26,955 rows for the third execution, right? But the execution plan says the first one, for the just 8 number of records, we have index seek and key lookup, which is superb. The second one, clustered index scan, we have seen like about like 1 million rows, right? 1 million, 1 million, 1 million. And then even for the last one, for 26,000 records, it also choose to do the clustered index. So how many plans are created here? Two different plans, right? So usually SQL engine will only save one plan in the cache, but here we are seeing multiple plans. So that is a PSP optimization. It saved for this particular executions. It created two plans. Now to see how many plans are saved inside the plan cache, we can run this query to see the number of use counts. 323 is the number of times we executed, and the plan handle. If you see the plan handle, we have three different plan handles. Three different one. Though it looks similar, it have generated three. These the plan handle looks different. The numbers are looking different. Three plan handles, and let's see, like let me execute this query and show you more details into the executions. Now these are the execution counts 3, 2, 3, and this one that is showing here is the latest one that I have executed. The user counts this one. This is the query that it is showing. So we don't have to bother about this particular one. But if you see the rest of one, right? Query text, query hash, query plan hash. Now let's focus on these two. Now, if you see, the query hash is similar because we executed the same store procedure, right? So the query hash is exactly the same, but the plan hash is different. If you see, so two different, like it created two different plans, right? So this is a plan having the same plan hash like this. So these two used the same exact plan, and this is a different plan. And you see the plan handle here, right? All the other information. And you can also see the query plan here and query text. Now to see more information, I have gathered the query reference from the Microsoft Docs. You can find this. I will also share more details. We executed just this query. Now let's execute this query and see what all information we get. The same information, like how many execution counts we have, query hash and the query plan hash. So query hash is exactly the same, but query plan hash differs because it generated two different plans. Now let me go ahead and clear out my procedure cache and query store as well. But before doing that, let me show you how the variants look like. I do not want to clear out everything before showing this. If you execute, now here we will see the information about the dispatcher plan, which have all the logic in it. And these are the query variants for all of them, for all the executions that I have done today. Like I have executed the other queries as well. So it has executed on that as well. It has created the variant plans on that as well. So let's see the query text. Now dispatcher plan should be this, let's say. Let's go ahead and see how the dispatcher plans look like. Now, dispatcher plans have the logic, right? So if you you do not see any much information on the dispatcher plan except like it shows like multiple plan. It has a logic in it where it will clearly says where to go and what execution plan to use. But if you see here, mm, These are the variant plans. These are the different plans that got generated for that particular dispatcher plan. So up till maximum 3 plans will be saved. It cannot save more than that. The maximum is 3 plans. And that too based upon the workload that you have. It will go ahead and save. Let me mute a minute. I need to cough. Sorry about that. So that is the second demo I would like to show. Now let me go ahead and share my screen. Let's talk a little bit about the memory grant feedback, persistence and percentile. So before moving forward with this particular IQP feature, let's talk a little bit about like how the memory grants are allocated and from where these memory grants will actually be allocated when a query gets executed. This applies to every single query running on SQL Server. So when a query, right, when a query runs on the SQL Server, the first time, if it doesn't have any execution plan already in place, or if the plan gets evicted out of the cache, the first thing that happens is like the query goes to the transformation phase, meaning it will create the different possible plans, multiple possible plans for that particular query. And on each of that possible plan, it will go ahead and do a cardinality estimation. Cardinality estimation is nothing but it will go ahead and check the column level statistics. Do you remember that we just saw in our demo the l- column level statistics on the column repetition? Every single query that runs in the where clause, it will search for that columns and it will go. If it doesn't have statistics, it will create the statistics and then it will fetch for the values within that particular statistics, and then it will allocate like it will go ahead and check the statistics on each of those possible plans that get generated for a query. And out of all of that plans, with this cardinality estimation values attached to it, it will go ahead and fetch for the lowest cost one. Meaning, like what for all of these possible plans, which plan will take only few resources to run, but still gives me the exact, still execute the query successfully. So it will do that, and the lowest cost one will be the winner. So that plan will be saved inside the plan cache. This all happens even before the execution phase. Now, while going into the execution phase, on like this particular plan cache, right? The plan that is inside the cache, based upon those estimate values, it will go ahead and allocate the memory grant for that particular plan. Now, let's say, let's say we are searching on a table where agent ID is less than 5, let's say. That particular query will actually produce 1 million records, let's say. But your statistics are stale. They are not updated. It's been long time. You forgot to look into it. Lot of data got inserted into that OLTP um, database. Inside the table, lot of data is inserted, and your auto update stats is turned off, and you did not do any updates to it. So your statistics are stale right now, and your statistics says for the agent ID which is less than 5, we just have 5,000 rows. But in actual, that same query will produce 1 million records. But the estimate is not saying that. It is just saying like you just get 8,000 records. So SQL Server will trust on that estimate, and it will allocate only the memory grant for that particular 8,000 records because it trusted the estimate, right? And then it will goes to the execution phase. But in execution, it will realize that we are going to get 1 million records here, but I did not get enough grant here. Memory grant is only for 8,000. Now, what do? I can't fail the query. Um, I can't get a more memory grant while I'm executing because memory grants are always allocated before execution. Now, what do? So there is no other option for the query store except to spill to disk. It will spill to disk, it will use the temp DB and then all sort of different operators that are not supposed to be used, and it will go to the execution. So the disadvantage here is it will it will take so much of resources. It will use temp DB, it will spill to disk, and the query will not run fine. It will take so much time, and and the performance is really really bad for that query, all because of this single thing, right? The cardinality estimates, the estimates are stale. So which will affect the cost, which will affect a wrong plan to be saved inside the plan cache. And based upon that, the wrong memory grants are allocated just because like of that particular estimates, and the query's execution happens. Query doesn't fail, but it keeps on running like 2 minutes to like several minutes to produce the results, right? That is because of this tail. So did you observe the link between the estimates and the memory grants right now? Memory grants are based upon those estimates. So they go along with each other, and you understood how much important memory grants are. Like if low memory grants are allocated, but the query needs more, that is a problem. If low memory grants are needed, but if the allocated memory is more, that is also a problem because the query runs faster, but it doesn't have to have that much of memory grant for that particular query. And and simultaneously many queries are running at the same time. We can't waste the memory, right? So that is a problem. So that's a background of memory grant. And why do we need the memory grant feedback? Based upon these cardinality estimates, like we discussed, the memory allocation of memory more or less happens. So the goal of the memory grant feedback is um, always to avoid those spills to disk, avoid using tempdb, like because it have to remove those spills. So this IQP feature goal is to remove those spills as well as allow the other concurrent workloads to run properly without without having any without having to stop the other process. Memory grant feedback is available in SQL Server 2017 for the batch mode and SQL Server 2019 for the row mode. But there is there is a difference in how the memory grant feedback worked on 2017 and 2019. We are going to see that in the coming slide. But the improvements that we have in SQL Server 2022 is like before SQL Server 2022, if at all you have to restart the SQL Server, the memory grants information that is collected will be lost. Or like if you want to fail over your database to the to a to a different second, like if you want to fail over your database, right? If you are using the always on availability group, even then the this information, gathered information, is lost. But with SQL Server 2022, the information is persisted even upon the restart, or if you want to fail over, the information is still present. And this particular IQP feature will use the query store feedback. Like all the information that is captured inside the query store, you know that all the information is captured, like memory, IO, and wait stats information, along with the query ID, query text, all that information is stored in the query store. So over time, as the information is stored, it becomes easier for the memory grant feedback to go ahead and analyze those queries and make an assumption of how much memory is needed for that particular execution. So query doesn't run one time, right? It have to run certain number of times for even SQL Server to decide on that feedback. So it have to validate. First of all, that query have to be eligible for the feedback to be collected, and then it will validate and then stabilize the feedback eventually. So before SQL Server 2022, memory grant feedback is only depending upon it only depended on the last execution, not the entire collection of the data, right? It did not collected all the info, only the last execution. So for example, um, if a query um, if a query needs the 800 MB of um, memory grant, it will take, but then the last execution took 5 MB. Then this time, though the SQL Server needs the 800 MB, since the last execution just used 5 MB, it will go ahead and allocate 5 MB, which is like, which is not right, because where do you get a stop point for that? The memory grants will be allocated, delocated, right? The last execution, up, down, and eventually the memory grant feedback will be stopped automatically. If it sees more fluctuations, then it will be stopped. Before SQL Server 2022, it is easier for the memory grant feedback to be stopped working because it only depends upon the last one. But with the memory grant feedback percentile in SQL Server 2022, it will grab the information from the SQL, like the query store, right? Over time information, and it will make sure it will collect and it will keep on um, it will keep on changing the memory grant feedback until it until it get um, even out even out with with the amount of feedback that is actually needed. So it will always make sure it is a little bit higher than the memory grant it is needed, but never lower than the memory grant needed. So it will use all that feedback from the query store, and then it will make sure it will grant the proper amount of memory. Now, if you disable the query store, right? If you disable, then these IQP features cannot get that information from the query store, so they cannot work on these feedback. The next one is interlinked with the previous one, the cardinality estimation feedback. Again, like I said, the cardinality estimates are the key, like to even decide how much memory grant or like what sort of a join it have to, like what sort of a operator inside the query plan it have to use, how much CPU it have to use. All of that sort of information is based upon these statistics information, right? So SQL Server will use three methodologies, the cardinality estimate techniques. I'm not going to go very much deeper into it, but I will give you an overview and you will get an idea of it. The first technique is predicate independence versus correlation. So, for example, if you are running select star from where city is Frankfurt and zip code is this much. If you see, both of the columns are interlinked, right? That they are related. The state and the city, or city and the zip code, right? They are interlinked. They are related. So if they are related, the cardinality estimate works differently and not optimally. So it will always force the cardinality estimate to go back to the default value. If that is the case, it will always use the predicate independence, meaning if the column values where you are searching, where the predicates you are searching are related, it will go ahead and make sure it will treat them as not related, predicate independence, and then it will do the estimates on the top of it. That's the predicate independence versus correlation. It will always use the predicate independence if there is a correlation. The next one is containment. Containment is based upon the joins. all about the joins. How many joins are being used? Based upon those joins as well, the estimates are calculated. The third one is row goal. How many rows do I predict to get as an output? That is the third technique it uses. So whenever a query runs with this particular feedback enabled, it will always verify if that particular query needs to be looked, because it have to be, the estimates have to be way too different. Like um, the estimates versus actual should be way too different for it to be considered for this feedback. Now it have to be 10x difference or like 100x difference. Estimate versus actual should be way different. There should be the difference between the number of records it thinks, as well as an actual how many it pulls, right? So there should be a difference um, to be even considered. And then it will always work on the queries which are always running all the time. It For this feedback to work, the query needs to be run certain amount of time, right? And then it has to estimate, and then it have to look for uh, which query plan is working fine, and then it will consider one of these plan by following all the feedback that it collects from the query store. What it does is, once that plan that it thinks, okay, this plan is working fine, if this plan gets executed, then it will give the proper estimates. On that plan, it will make sure it will enable a query hint for that particular plan to be forced. And the next time it runs, once that particular plan is set in place, it decide uh, that plan should be used. It will force that plan by using the query hint, query store hint, and then the next time it runs, it always uses that plan. So that's how the cardinality estimate feedback works. Again, you need to put, all you have to do is place the compatibility mode to 160, and repeating queries with the persistent plans will be considered. It will always verify on the feedback that it is being implemented. Then only the query hint will be used. It have to verify that it is working. The last one is DOP feedback, degree of parallelism feedback. This feedback will always make sure, um, if at all your queries doesn't need to run with so many max stop setting, like max stop 5, like it doesn't have to use so many CPUs. It will always make sure, like it will decrease the DOP to use up till 2. It will not go below maxed off value of 2. It will set up till 2. But at the same time, it will not increase your DOP maxed off value. It will always make sure it is using low DOP value, and it cannot decrease more than 2. It is all about like saving the resources, right? By using the query store data again. And you can find what feedbacks are available by looking at the view query store plan feedbacks. And again, the query have if it will check if the query is actually enabled, then it will start collecting the feedback to stabilize it. Before stabilizing it, it have to validate for certain amount of time, and then it will go ahead and stabilize that max stop value. And you can always see those feedbacks on by using the view query store plan feedbacks. Um, yeah, so if you would like to go more in depth of like this particular topic on each of this IQP feature, please visit this links. It have lot of information. It's like an extension to this session, I can say. I'm still building this presentation. I have to do a lot of demos on top of this presentation. I'm still in the process. It's not that easy to make sure these features work as expected, especially through our demos. So I'm still in the process. So hopefully you like the session, and I would like to thank Michael for giving me this opportunity one more time, and thank you so much for attending the session.